This question is testing whether or not you understand what's going on with the velocity time graph. And we're told that we've got a velocity time graph for a ball that's dropped from rest and bounces repeatedly. So think about it, imagine a ball being dropped and bouncing, hitting a desk or a table. Okay, so we've got that idea. Now, if we look at the four graphs available, so this one has initially the ball starts very slowly, has a non-uniform acceleration. So its acceleration starts off large and then decreases, which sort of is plausible, maybe a bit at very, very high speeds, but not a ball that's been dropped in a normal situation. Anyway, its then velocity remains constant, and its velocity, so it falls, remains constant, slows down to stop, but then goes again in the same direction. So you release the ball, it moves away from you up to a maximum speed, then it slows down and stops, and all the time it's moving away from you. This is weird and it's wrong. That's not correct. The next one, you drop it and it falls with a constant acceleration. Okay, so the acceleration is in the same direction as it's moving. So if you dropped it from a height above the ground, it will be accelerating downwards. Then you get a dramatic change and it changes direction. So then it's going from say, downwards to the opposite direction at about the same speed, and it's going upwards at that collision, and that's a very short collision. Then it continues, so it's going in the opposite direction. It slows down and slows down, so it's going fast upwards in the opposite direction, slows down so it stops. Then it starts to accelerate down, well, it continues accelerating downwards. So, release the ball, hits the floor, is moving upwards at a speed equal to the speed, so it's an incredible sort of magical bounce, is going upwards at the same speed that it hit the floor, slows down, stops at its maximum height, maximum bounce height, then gets faster and faster and faster until the floor hits the floor again. Same thing happens. So B is plausible, and it's certainly the best one so far. C, it starts off moving very fast. So you've not released it from rest. It starts off really fast. This is wrong because it hasn't been released from rest. It then slows down to a stop, then magically speeds up. It could be, you might think that's a bounce, but then it magically speeds up and goes in the same direction. So it hits the floor and then continues through the floor. That doesn't make sense. Then, so C is wrong for a number of reasons. D is released from rest. Non-uniform acceleration. The acceleration is getting bigger and bigger and bigger and bigger until it hits it, but then it keeps going in the same direction. So it hits something and then goes through it. So again, D is weird. So the only one that has a change of direction is actually B. So this could be a very fast answer because B is the only one that could possibly be right if you look for the right things first.